Hello, here's a quick review on factoring. This would be to go with our day 3 worksheet factoring review. So the first thing that you always want to do is look for a GCF. Factor out the greatest common factor. So I look at this and I know that there's a greatest common factor because they're all even numbers. So let's see, if I divide 70 by 2, then I'm going to be left with 35, which is only divisible by 7 and 5. And 18 is not divisible by 7 or 5, so it must be 2. And then I also notice this negative here. If it starts with a negative, I'm always going to factor that out. I never want to start with a negative. So I'm going to factor out that negative 2. And I will have 9x squared minus 58x minus 35. All right, next step, we have a trinomial. And remember, trinomials, we are going to guess and check. I'm looking at my signs, and both of them are subtraction. So, well, actually, the second sign is subtraction. So there's going to be one of each sign in my parentheses. I don't know which is which yet, so I'm going to write them in a moment. And then I look at my 9 and I look at my 35. For 9, we could do 1 times 9, or we could do 3 times 3. 35, we could do 1 times 35. Or we could do 5 times 7. So really, it's just a guess and check kind of game. I need to put numbers in and see if I can get the middle term. So 3x times 7 is 21x. And then we've got 15x, and that will not make 58. If I switch the 5 and a 7, I'm just going to get the same numbers. So how about I try 9 and 1? So 9x times 7 is 63, and then 5 and x is 5x. And together, if I subtract those, if I do 5x minus 63x, I will get a negative 58. So I need to set up my signs so that I have negative 63x. Okay. And that one was just a little bit more challenging than the ones that start with a 1x squared, but it's definitely doable. All right, the next one, we have a 2-term binomial. I'm going to always check for my GCF. And I look at 125 and 64, and I do not see a greatest common factor, but something really stands out to me. 125 and 64 are perfect cubes. So we have a formula for factoring a sum or difference of perfect cubes. That formula, I think we learned in chapter 4. Yeah, we learned it in chapter 4. So here's the formula. If we have a cubed, I'm going to put plus or minus b cubed, we will factor it with 2 parentheses. The first parenthesis will be a plus or minus b, and the second parenthesis will be a squared, so whatever's in this first parenthesis squared. Then it's going to be minus or plus. Then it's going to be ab, and then it's always going to be plus b squared. And then one other thing that we talked about back in the day is this trinomial will never factor further. Okay, so once you get the trinomial here, you don't even have to check to see if it factors further. So right now I have a cubed and b cubed here. So my a value would be 5a. My b value would be 4. And because it's subtraction, I'm going to use subtraction. So over in my chart, let me color code this. If I use subtraction here, then I use addition here. Or if I use addition here, then I use subtraction here. But the last sign is always addition. So now once I've done my first parenthesis, I use my first parenthesis to get my second parenthesis. I use 5a, but I'm going to square it. So I'm going to do 5a times 5a, 25a squared. Then I use the plus sign. In the middle, I multiply the a and the b together. So that's going to be 20a. And okay, so the original sign is supposed to be a minus. It's supposed to be a minus here. But since I'm multiplying together 5a times -4, I actually get -20a, which is why I end up with a positive when I'm done. So that's why I know that it's always going to be a positive here if there's a minus here, because we're always going to get negative and negative, or minus and negative. So this these signs over here can be just a shortcut. Okay, and then it will always be positive here, and I multiply 4 times 4, which is 16. And then, like I said, the second trinomial, the second parenthesis, will never be able to factor further, so this is it. It was a difference of cubes. Okay, next one, I'm going to look for my GCF. First thing I'm always going to look for, and I see a negative, so I'm going to want to take that negative out. I see a 3 and a 6, so definitely a 3. There's a squared and a to the third, so a squared in both, and they both have at least a b. So I'm taking out -3a squared b. Now, in the first place, I'm taking out the entire thing. That does not mean there's a 0 there. So these cancel, 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 but when you have something on top of itself, it equals 1. So you got to make sure you still have that 1 there. And then for this one here, oops, I put a plus sign, it's minus. We'll have a -2, an a, and a b left over when I subtract the exponents. You should be able to check your answer by distributing. If we've done it correctly, you should be able to check your answer. So if I multiply this back into the 1, it should equal the original binomial. So now with 1 minus 2ab, that is not a difference of squares, and that is not a difference of cubes, and there's nothing in common. So there's nothing else I can do. Some of these, you will only factor out a GCF and be done. That's it. All right, 4 terms. First of all, look for a GCF. Is there a GCF in all 4 terms? There is not. So when we have 4 terms, we do factor by grouping. In factor by grouping, you have to have a plus sign in the middle. So where I have a subtraction sign, I'm just going to change that into plus and negative. And now I have a plus sign in the middle. And you're going to group your terms. And then within each group, we're going to look for a greatest common factor. We're going to start factoring in just each group. So for this group here, I do have a greatest common factor of 8x. So I take that out, and I'm left with y plus 7. In the second group, I have a greatest common factor of just -1. So I have -1. And I have y plus 7. So now what I've done is I've formed a really complicated looking binomial. And in this binomial, this is a term and this is a term. And in this binomial, I'm looking for a greatest common factor between the terms. So y plus 7, I can factor out of both of those. So it goes in front. And then whatever is left goes in the second parenthesis. So I have y plus 7 multiplied by 8x minus 1. And then we always have to check y plus 7 to see if that can factor further. But since y is a first power, it does not factor any further. And same thing with 8x. Since x is a first power, it does not factor any further. So this would be the answer. Okay, and then the last example is 16 minus z to the fourth. I look for a GCF, which there is not a GCF. If there was, I'd have to do it first. And then I'm going to look what I have. I'm looking at 16 and z to the fourth. This is a fourth power. A fourth power is not a cube, but a fourth power is a perfect square. It is z squared squared. So it is z squared multiplied by itself. So that is a perfect square. 16 is 4 times 4, or 4 squared. So 16 is also a perfect square. So we're using our difference of squares. And I'm going to have 4 plus z squared minus 4, multiplied by 4 minus z squared. So I factor it down into conjugates. 1 is plus, 1 is minus. And because these are z squareds, I'm going to check to see if they can go further. So I look at 4 plus z squared. 4 is the perfect square. And z squared is a perfect square, z times z. But the plus sign in the middle is a sum. And we do not have a sum of squares. We only have a difference of squares. So I cannot factor this first parenthesis any further. The second parenthesis is a difference of squares. So this one I will factor to be 2 plus z and 2 minus z. So this one has 3 separate factors when we're done. All right, let me know if you have any questions on the worksheet. Have a great day.